representation of the system and not on the lower level. Okay. So in that, as I mentioned, that whenever we talk about architectural representation, we always talk about the functional blocks. Okay, there are 5 blocks or 7 blocks depending on the system. Okay, for instance, if you have a railway reservation system, okay, so there we have account creation, payment, uh, ticket booking, cancellation. They are all nothing but the various functional blocks. And how these functional blocks are communicating with each other, how they are arranged, how they are connected. So that is nothing but the architectural representation. So we generally call it as a structural, overall structural representation of the various components of a system as a whole. Okay. So in IoT also we have various functional blocks like device, communication, services. So devices are very much required because we are talking about devices that are connected to the internet. Okay, so SAMC I'll explain. Okay, so sensing, actuator, management and control, and I'll explain each and everything. So first of all, we require devices. From the devices are going to communicate, so we require communication protocols. Okay, so when the devices are communicating, they're exchanging information. So we are talking about services, what type of services these devices are going to provide. Then if millions of devices are connected to the internet, who is going to manage? Okay, and then when the communication is taking place, there is exchange of data, so we require security. And on the top we have got the user interface or the application. Okay, so to avail those services provided by those devices that are connected to the internet. Okay, so a device is nothing but a sensing device. An IoT system comprised of devices. Okay, so what the devices will do, they'll sense, they'll take some actions called actuation, then monitoring and control functions. So every device that is connected to the internet, they are the sensing devices. Based on the sensors, they may take some action. If you talk about robotic devices and all. Okay, so sensing, actuation, or if it is a voice assistant like Alexa, if you ask something, then based on that your text, depending on the language, it will respond or take some action. Okay, so we have sensing, actuation, monitoring and control. Okay, so how these devices the data that is collected from the devices are actually monitored, and what are the control functions that are involved with reference to this devices. So sensing, actuation, monitoring and control function, they are related with the devices that are connected to the internet. So when the devices are connected, they are going to communicate. Okay, so this acts as a handles the communication for the IoT system. And then services, because the devices are connected to the cloud, and we know that cloud is one of the major service provider platform, but infrastructure as a service, software as a service. Okay, or a platform as a service. So services for device monitoring, device control. Okay, so in the here I have mentioned here services, that is device monitoring, device control. Okay, so data publishing services and device discovery. So these are some of the services that I have mentioned. Okay, so services for device monitoring, how you are going to monitor your devices that are connected to the internet. Okay, how you are going to control the services for which they are connected to the cloud, and what type of data that has been sent to the cloud, and how you are going to do the analytics with the data. So data publishing services and services for the device discovery. So I've got devices, I've got communication, I've got services, then management, how these blocks provides various functions to govern the IoT system. So I know that various blocks are there. Okay, how these blocks are very much mandatory as far as creation of the entire IoT system is concerned. Okay, and all these are related to the services that the devices is going to provide to the user through cloud. Okay, so that's why management plays an important role. So since the data exchange that takes place, so security is also very important. Who is the authorized user who can access that particular data that is sent from the devices to the cloud. So this block secures the IoT system, and by providing functions such as authentication, authorization, message, content integrity, and data security, all security related issues. Okay. And finally, on the top, we have the users. So we have the user interface. So there is an interface that the user can use to control or monitor various aspects of the IoT system. For instance, you want to control your fan, you want to control your bed lamp. Okay, so that can be done through mobile phone with a proper interface. So application allows user to view the system status and view or analyze the process data. Okay. So these are the various blocks are there, and these blocks can be arranged either horizontally or the combination of horizontal plus vertical partition. So that is what the architecture actually means at the higher level of representation. What you call an abstract representation of any system is nothing but uh, the collection of various subsystems or the modules, and every subsystem has to provide some services. Okay, and it will look like this. So this is one such architectural representation of an IoT system. So I have got the device, I have got which is nothing but horizontal layer. So these are horizontal layers, and I've got some vertical partitions. In the vertical partition again, I've got some horizontal layers. Okay, so this is how these functional blocks are arranged. So this arrangement is nothing but what you call the architecture. Okay, and then so this is one such layered architecture. We have different categories: client, server, layered, data repository, different categories of the architectures we have. So this is something what you call a layered architecture. Okay, so at the top I have got the application or the user interface, and I've got the sensing devices at the bottom. And through this, all these are the intermediate layers. Okay, so every layer is nothing but a subsystem, and they are going to provide some services to the user. So since we have the devices that are connected to the internet, so how the communication is going to take place? The communication is always based on some protocols. Okay, so we have some communication models here, what you call request response. Okay, for instance, you want to search something in Amazon or you want to search something in Google. So you type your text and then you click your search button. So what you are doing, you are actually sending a query or a request to the Amazon or a Google server, and the Google server then refer to their repository and respond immediately within milliseconds or nanoseconds rather. Okay, so depending on the speed of the internet. So this is what you call request response. You're sending a request and the server is going to respond accordingly. Similarly, we have public subscriber. Okay, so this MQTT protocol that I mentioned, so most of the IoT applications are based on that MQTT because they're a very lightweight and very fast communication protocols we have in IoT systems. So they are based on public subscriber. Okay, so what is public subscriber? We'll discuss. Okay, similar to what we have sender and receiver. Okay, sender will public a particular message based on some topic, and the subscriber will subscribe that particular content. Okay, for instance, uh, you have registered for any Coursera course from Stanford or NPTEL course or SWAYAM course. Okay, so you can access those courses that you have registered or that you have subscribed. Okay, so and from the client side, the NPTEL provided all the list of the courses on the website with based on corresponding topic of whether it's a mathematics, engineering, IoT, blockchain, AI, okay, digital logic. So based on the topics, the subjects are listed, and you have to subscribe which topic you are going to choose. Okay, for your learning. Okay. Similarly, we have push-pull communication model because, as I mentioned, that the billions of devices are going to be connected to the net. So every device must has its ID. Okay, so that is what you call API key, application programming interface. So this I'll tell you when you talk about ThinkSpeak IoT cloud. Okay, so so you have to push the data from the devices to the cloud. Okay, so that is what you call push API. So once the data from the devices are pushed to the cloud, and you as a user, you pull the data from the cloud. Okay, so we call it as push-pull communication model. Okay, or push-pull architecture. Similarly, we have exclusive pair architecture is also there, or a model. Okay, so these are some of the communication models we have, and the most commonly used a publish subscriber. Okay. So as I've given request response, you send a request. Okay, sends request to the server, and the server is going to find out based on the resources that he has. Okay, so it fetches the resources and will send to the client. It's a simple client server mechanism. Okay. So most of the searching that you do in Amazon and all, so that is all based on HTTP client server model. Okay, HTTP protocol. Okay, hypertext transfer protocol. Okay. So similarly, publish subscriber, the example I've given, MQTT protocol that is used for most of the IoT system. So there is a publisher and there is a subscriber, and nothing but the consumers. So consumers are nothing but the subscriber, and there is a broker which acts as the intermediate server. Okay. I'll show you what are the most common server that we use. That Mqtt Broker is actually a free communication protocol that is used for IoT and is actually developed by IBM. So publisher, what do we do? It send messages based on the topics. So message publishes to a topic, and we have different topics. For instance, uh, if you're searching for any learning content, maybe this is mathematics, physics, chemistry, engineering, mechanics, like this. We have different topics, and as a user, you subscribe and you register for that course and you access the content. Okay, so that is what publisher and subscriber means. Okay, so you publish the data means you send the data, and subscriber are nothing but the receiver, they'll receive the data. Okay, so so the same example I mentioned, so publisher and they are the subscriber. Okay, so and I have a notification service provider will be there, which will provide notification that a such and such topic has been published. So the subscriber will get a notification whether you want to access or uh, whether you don't want to access. So those who want to access, they'll register and get the information published by the publisher. Okay. So there is also the same example how it actually looks like publisher based on the topic. Okay, so it will be listed at the broker side. Okay, and then I've got the subscriber. One example I've given, customer relation management is a publisher. Okay, and so where there are different subscribers, subscriber related to the billing topic, subscriber related to the GIA, subscriber related to the messaging. Okay, so based on the different topics, we have got the subscriber will subscribe and access the content published by CRM. Okay, so various types of publish subscribe implementations we have. Okay, so one is from Microsoft Research, IBM, from University of Colorado, University of Cambridge. So we have different types: Scribe, Gryphone, Sienna, Hermes. Okay, so we have different types of publish subscribe implementations. And the same mechanism also we use in what we call Java messaging services. Okay, so there is a client. Okay, so the client will publish based on the topic, and the subscriber, they are going to use that particular content that has been published by the publisher. So this code you leave it. Okay. So I mentioned that push pull communication, as I'll give an example of ThinkSpeak Cloud. So there I've got the concept of API keys. So API, because every device must have a ID. Okay. So that ID is nothing but the API key. Okay. So in push communications sent to specific recipients who need to receive the information, and this ensures that the information is distributed, but does not ensure that it actually reaches or was understood by intended audience. So you just push the data. Okay, it won't give any confirmation whether it will be understood by the subscriber or not. So push communication includes letters, reports, emails, fax, voice. Okay, so I've given an example of notification. For instance, so in smart farming, you want to plant water. Okay, so if the moisture sensor the reads the content, the data of the moisture level, and if it is less than the threshold, then it'll send a notification to the owner of the house or a farmer. Okay, so that is what you call one such representation as far as pushing communication information to the cloud is concerned. Okay, so whether you are sending a mail or an SMS or a blog or a press release, so you just push that particular information to the cloud. Okay, through API key. So if the user want to access, so used for very large volumes of information, for instance, in a YouTube channel, a huge number of videos are uploaded. Okay, so that's a very large volumes of information or very large audience, and requires the recipient to access the communication content at their own discretion. So this method includes internet sites, e-learning contents, learning database, knowledge repositories, where huge amount of data is stored. Okay, huge amount of data is required as far as communication is concerned. Okay, so this is how it actually works. You publish the content, and the subscriber or the consumers, they'll access the information. So you push the data to the cloud, and the users will subscribe, and then they'll pull the data from the cloud whenever it is required. And similarly, in an exclusive pair, for instance, if you talk about you want to do some sort of transaction with ATM machine. Okay, so as soon as you insert a card, the ATM will ask the PIN number. Okay, then you enter the PIN number, then the ATM will ask enter the type of transaction. Then you will select a type of transaction, for instance, withdraw. Then the ATM asks the user how much amount of money you want to withdraw. So like this, a question answer that takes place between the you and the ATM machine. So until unless the entire transaction is complete. So that is what you call exclusive pair. Okay, so you are pairing with the ATM system. Okay, so that is actually a transient behavior because you are not a permanently related with the ATM. So you are related only for few minutes when you are doing interaction with the ATM. So once the withdraw money is over, then you take the card, take the receipt, and your relationship breaks there. Okay, so that is what the complete cycle runs, okay, between yourself and the ATM. So here also in the client server, so as soon as the interactions or the transactions are initiated, the relationship is established. As soon as the transaction is over, there is no more relation. Okay, some other person will come and interact with the ATM. Okay, so this is what you call exclusive pair communication model. Okay, between the client and the server. So this I'll discuss in the next class, WebSocket based. Okay. Uh, okay. So because I talk about this MQTT, okay. So the MQTT is the most commonly used protocol, okay, in most of the IoT system, and it is called as message queuing telemetry transport. Okay, message queue telemetry transport, and this protocol is actually developed by the IBM. So very is it's a very lightweight protocol, and because the devices that were connected, they are the resource constraint devices because they operate on a battery on a less voltage is required. Okay, so that's why, and they have less memory. Okay, so ideal if processor or memory resources are limited. So as most of the connecting devices or the IoT devices, there are resource constraints. They have less memory, less processing capability. Okay, so that's why they are sending data to the cloud where all the services are available. Okay, so ideal if processor or a memory resources are limited. So constrained uh, devices, what you call resources are constrained. Even if the bandwidth is low or a network is unreliable, it works on the top of TCP/IP. Okay, so it works on the TCP/IP protocol. Okay, so there is a basic protocol we have, communication protocol. Okay, so that's why for a low bandwidth, these IoT devices they has to work on low bandwidth. Okay, so and they are battery operated. Okay, their processing and memory devices are very limited. Okay, so that's why you call it as resource constraint devices. Okay, so these are some of the features as far as this lightweight protocol MQTT is concerned. So it is based on what publisher subscriber, what you call pub sub model. Just now we have discussed that publisher subscriber. So the publisher is what? Publisher is a sender. So he'll send the data to the cloud. Okay. What is a subscriber is a receiver. Will collect the data from the cloud. So that's why we called as a publisher subscriber. So then we have broker in the topic because I mentioned that there is a broker. So broker is nothing but a server which will connect the sender and the receiver. So there is a sender and the receiver, somebody has to connect them. So we require a broker. So broker is nothing but a server. So in that diagram I have shown, there is a broker and a topic on which topic the message are to be shared. Okay, because the client will send a message. So the messages are coming from different clients. So they have to categorize on different categories as based on the topic. Okay, so the broker is nothing but a server which connects both sender and the receiver or publisher and subscriber. So topic on which topic the messages are to be shared, and the MQTT protocol, every protocol has to work on some port number. So it work on 8883 port. Okay, and the broker is AWS IoT endpoint. This I'll show. Okay, so because I'll discuss about AWS IoT core. Okay, so there So AWS IoT endpoint acts as a broker. Okay. So broker for the timing, remember that it's a server which connects publisher and a subscriber. Okay, as we have client and a server. So here also we have publisher and a subscriber, what you call sender and a receiver. Okay. So various applications where this MQTT is used: smart homes, smart cities, health, agriculture, smart industries, everywhere. So we call message queuing, telemetry, transport. Okay. So this is an example that I have a temperature devices, for instance, that is connected to my Raspberry Pi. Okay, and it publishes the temperature and what is the topic? Temp is a topic. Okay, because whatever the data is published, it should be categorized under some topic. Okay, so we are sending data uh, from the Raspberry Pi to the cloud. So we are publishing a data. There is nothing but the temperature sensor, and for instance, the topic is temp. So who is going to send the data to the cloud? So we require a server. So that server is nothing but MQTT broker. Okay, so this is a free software we have. Okay, which we can use, readily available, open source. So now MQTT broker will take the responsibility of sending data, okay, to the subscriber or the cloud. Okay, so it publishes the data. Okay, the subscriber, for instance, here one subscriber is computer, one person is using mobile phone. Okay, so they are going to subscribe. Okay, or they are going, for instance, in simple words, they are going to register. So then only they get the data. So here also publish the data, and there is a subscriber to temperature, mobile device, computer, any other device. Okay. So temperature sensor is nothing but a publisher. AWS endpoint is nothing but a broker. AWS IoT core is nothing but a subscriber. I'll give an example how this is done. So for the timing, you remember that MQTT protocol is a lightweight communication protocol, works on publish subscriber model. So publisher will publish the data and subscriber will subscribe the data from the cloud, and MQTT broker will act as a server which take the contents from the publisher and put into the cloud. And then from the cloud, there are various subscribers. They'll register for that particular topic and they can access. So here we're talking about the temperature. So temperature sensor is nothing but a publisher. AWS endpoint is nothing but a broker, and AWS IoT core, because you're sending data to the cloud. Okay, so AWS IoT core is nothing but a subscriber. And the broker is nothing but a server which puts the data from the client to the server. So let us see a overall picture of how AWS IoT core actually works. Okay, so assume that this is my sensing device, a Raspberry Pi connected to a temperature. Okay, so we can call it as a device SDKs. So set of client libraries is to connect, authenticate, and exchange messages. So I assume that this is my Raspberry Pi connected to a temperature sensors. Okay, now this data has to be sent to this cloud. There is nothing but AWS IoT core. Okay, so that is possible through these steps. So first you have to create some securities for your device. Okay, secure with mutual authentication and encryption. So we have to create some policy, we have to create some certificates. Okay, so that is nothing but every device must has to follow some policy. So every device must have an ID. So that is nothing but your certificate. Okay, so that is all for authentication itself. So then I got the message broker communicating with devices by MQTT protocol. So this is responsible for collecting the data and putting into the IoT core. Okay, so then so while it is put into the IoT core, it has to follow some rules engine. Okay, so what this rules engine means, if your temperature is greater than this, then what is the action that the system is going to take? So you have to frame some rules. Okay, so that is called rules engine. If temperature is greater than this, if humidity is less than this, what actions you're going to take through AWS. Okay. So that's why rules engine transfer messages based on the rules and route to AWS services. Okay, so once the temperature is sent after creating a policy and certificate, it will pass through this rules engine. Okay, then it will decide based on the rules, it will route this data to the AWS services. Okay, so there is shadow is also one such service in AWS. Okay, so it's a persisting persistent thing state during intermediate connections. Okay, so there's called your shadow services provided by the AWS. Okay, then it's connected to the desired application. Okay, whether it's a desktop or a laptop or a mobile phone. Okay, from where you are accessing this content. Okay, published by this Raspberry Pi. So we have other services like identify and management of your things, then AWS IoT API. Okay, so different types of services are there. Okay, so AWS IoT Message Broker that I've shown, what it does, it takes the data from the publisher. Okay, so based on the topic, so if you, whether it's agriculture, whether it's related to some e-learning content, so it will segregate based on the topic and send to the cloud. Okay, so highly scalable message worker, so it collects the data and based on the topic it will segregate to different sections. Okay, so standard protocol support, millions of devices and apps can connect over any protocol starting with MQTT and HTTP. Okay, so long-lived bidirectional messages. Okay, if you talk about communication, you can communicate with the device, and the device can also communicate with you through IoT gateway and cloud. So the client, devices, and application can receive commands and control signals from the cloud, and they are secure because AWS IoT Core provides security based on the policies and the certificates that are created. So connect securely by X509 certs and TLS client mutual authorization. Okay, this is nothing but a part of security. I'll discuss this. Okay, so what is the difference we have? MQTT is much faster as compared to HTTPS. So MQTT is a lightweight protocol, so it work in low bandwidth. Okay, so less batteries to send, less battery to receive, less power to keep connected, less network overhead. So all this is possible with with respect to the MQTT communication protocol. So it's a lightweight publish sub transport protocol that is useful for connected devices. Okay, so used on oil rigs, connected trucks, and many more sensitive and resource sensitive scenarios. And the customer have needed to build, maintain, and scale a broker to use MQTT with cloud applications because your cloud services should have an option of scalability. Okay, so if because the number of devices they are very large, data generated is very large, so this the cloud can also scale. It can accommodate or improve its processing capability. Okay, so security and authentication. Okay, so whatever the device that you want to connect to the cloud, it must has to undergo this process of authentication. Okay, so for that you have to create some certificates. So secure communication with things. So a single API call to create keys and certificate. Okay, so some certificates is created because some sort of encryption will be there. Okay, so fine grained authorization for thing management, publish subscribe, data access, AWS service accesses. I'll tell how this policy and certificates are created. So once your device is registered through some policies and certificates, okay, then it passes through the rules. Okay, because once the data is collected, what type of actions to be taken based on the content that is received from the publisher. Okay, so some rule engines are there. Okay, so for here some sample example, it is turn to lambda, turn to this. Okay, so simple and familiar syntax, statement to define topic, optional, and so you can write your own rules in AWS. Okay, depending on the type of the application you're working on. Okay, so that is what a rules engine is. There is something there in expert system in fuzzylogy also. Okay, because once the data is collected, how the decision will be done by the cloud or the corresponding actuators that is connected to the end devices. Okay, so this is what it is mentioned. So there is a rules engine. So rules are framed. So based on the rules, some action has to be taken. Okay, so action may be in terms of AWS services or rest of the services that we have. Okay, so services may be related to storage. Services, Kinesis is also one such services. We have Lambda SQS. Okay, single notification service. So different types of services are there. Which services you want to avail based on the actions that you have that you want, depending on the rules that you have generated. Okay. So different types of actions are there. Okay. So invoke a Lambda function, put object in an S3 bucket, insert update read from DynamoDB. These are all there as a services in AWS. Okay. So your application or your based on the data. So rules has been created, and based on the rules, some action has to be taken, and this action is nothing but connected to the services. Okay. So the first thing that we have to do is we have to create a policy. Okay, why we require a policy? What is this policy? Policies define which operation or resources a device or a user can access. Okay, I'll give an example also. So policies nothing but define which operations or the resources a device or a user can access, because there are so many services are there in the AWS. Okay, so you define, you create a policy. Okay, you create a policy and define which operations or the resources so device or user can access that is available in AWS. So AWS IoT policies grant or deny access to AWS IoT resources such as things and MQTT topics. Okay, so once you create a policy, you want to use some services of the AWS. Now AWS will accept your grant or reject your grant. Okay, depending on your application. So one such example is greenhouse policy. I'll show how this policy is created. Then I'll go for certification. Okay. So hope you have you all created your own account in AWS. Okay. So here in the services, you see this is something that I've already shown you when talk about cloud computing. So these are the resources, services from compute side, then robotics, machine learning, augmented and virtual reality. So different services we have. Okay. So let me type IoT core. So I'm looking for IoT core. Okay. Because I have to IoT core acts as a subscriber. Okay. So as soon as you open this your AWS account, okay. So these are the services that I've already shown. Okay. Then AWS IoT is managed cloud platform that lets connected devices like cars, light bulbs, sensor grids, and more easily and securely interact with cloud applications and other devices. Okay. So there's your the front page. Then in the left hand side, you see, so there are various mechanisms are there on board, whether how you're going to manage the devices, the green grass IoT, security, defend, act, test. Okay, so different facilities are there. So on board you see get started, fleet provision templates. You can just explore this. So first we're talking about policy. So in the secure you see policies here. So you click policies here. So here some policies I have already created. Okay. You can create a new policy. In the right hand side you see you click a create button. So you create a policy. Okay. BIC. So this is a policy that is created. Okay. So create a policy to define a set of authorized action. You can authorize actions on one or more resources, whether things, topic filters. To learn more about IoT policy, you can see this document. Okay. So every time when you want to connect your Raspberry Pi with a sensors to the AWS, you have to create a policy. This all comes under security. Okay. So you create a policy to define a set of authorized actions. Okay. So you can authorize actions on one or more resources provided by the AWS. Now here you see here, please use comment to separate actions here, whether what are the actions you want to publish data, then you can write IoT : publish. No, I want to subscribe. You can write IoT : subscribe. So I want to do all the actions that are available. Then I have to write IoT colon asterisk. So this indicates all the different types of actions that are available that I want to do. Okay. Then I've got emergent resource number. So as soon as you create a policy, so this emergent resource number will be assigned. Now you allow this. So you allow the creation of the policy. Okay, so there is nothing but your emergent resource number with reference to the policy that you have created for your particular device that you want to connect with the AWS. Okay, so then you select allow, then right click create click here. Okay, so you see here successfully created a policy. Okay, so there is a policy that I have created. See here, I have created a policy. Now you click this. So you see here the details. So the policy is created here. Okay. So the version 1 statement. So you have allowed a policy. The action is all actions involved. So there is a emergent resource number associated with that policy. Okay. So here the policy is created. In the left hand side, certificates, versions, groups, and non-compliance is there. Okay. So if you click so these are AWS resource number for that policy. Okay, you see here EC BIC. Okay, there is there. Okay. Then in the top hand side, you'll see some actions are there. If you want to delete, you can delete this policy. Okay. So this is how a policy is created. Okay. Now if you want to see certificate, so no certificates is attached to this policy. Okay, you don't have any certificates attached to this policy yet. So let's see versions. So because the policy is allowed. Okay. So we have this also I have shown. Groups, you don't have any groups attached. Non-compliance. Okay, no non-compliance. So we have just created a policy. Okay. So certificate we have to create next. Okay, so that's why I mentioned here certificate. So first step is to create a policy, and the next step is to create a certificate. Okay, why this is done? This is done all for authentications, because you are connecting a particular device that is connected to your ordinary or Raspberry Pi board to your cloud, and you want to avail the facilities of AWS IoT Core. So for that, some authentication is required. You must be your device must be registered to perform some actions or some receiving some services from the AWS IoT Core. Okay, so policy you have created. Now you have to attach that policies to the certificates. So what is a certificate? Is a communication between your devices and AWS IoT is protected through the use of X.509 certificate. So we have some standard certificates are there. Okay, so the communication between your device must communicate with the cloud. There is nothing but AWS IoT. So the communication should be protected. Okay, so communication between your device and AWS IoT is protected through these certificates. Okay, so there is nothing but some sort of encryptions are there. Okay, like passwords are generally encrypted. Okay. So X.509 certificates are digital certificates that uses the public key infrastructure standard to associate a public key with an identity contained in a certificate. Because it is a digital certificate, it is encrypted. Okay, because once the certificate is created for a particular device, you can't able to read that because it is encrypted form. Okay. So AWS IoT can generate a certificate for you, and you can use your own, or you can use your own also. Okay, so we generally create them. Okay, so how to create a certificate? So let's go this. So here you see in the secure, here you have got the certificates. You click that certificates button. Okay. Now, so these some certificates are already created. I'll create a certificate and attach to the policy that I have created. Okay. So here you see, so you create certificate, you can create here, click create certificate. Okay. So you see a successfully generated certificate. Please download certificate files. Okay. So you see here. So as soon as you create a certificate, download these files and save them in a safe place certificates can be retrieved at any time, but the private and public keys cannot be retrieved after you close this page. Okay, so all this for authentication. You see here a certificate for this thing. Okay, then a public key and a private key. Okay, so you also need to download the root CA for AWS IoT. So this I'll tell what this root CA. So like this, you can create a certificate and you can download and save it. Okay. Once you have done with this, then you have to activate that. Okay. So successfully activated certificate. Okay. Then, so once the certificate is created, because I have not downloaded here, because you can download and save it. Okay. Once your certificate is created, let me download also. Let me download for you. So .crt is an extension of this. Okay. So most of the digital certificate will have this extension. So you can save this. Then you attach a policy to that certificate. So how you're going to attach, you see here, you are attaching a policy to the following certificate because a certificate is created a sort of digital signature. Okay, now select a policy to attach the certificate. So I'll attach this to EC BIC. Okay, then you're done. So now you see successfully attached policy. Okay, now here you see. So it is inactive. You can select a button, you make it active. So the certificate will be attached to the policy. Okay. Let's see there. So you see here how this what is there inside the certificate. Okay, so this is all encrypted form. Okay. So this is what a certificate is. So a policy is created and a certificate is attached to that. Okay. So this is how even when you create a policy, you'll see this is a policy that we have created. There's an emergent resource number that has been given to this particular policy. Then here in the certificate you see, so see the certificate is created. Okay, so there is a certificate. Okay, so the details about the certificate, when it is created, when it is effective, expiry date. Okay, and here you can see whether you want to activate it, deactivate it, everything is there. Okay, I want to delete it. Okay. So I've created a policy and it has a certificate to the policy. Okay. Then next, there are plenty of steps are there. It's not easy by connecting devices to the AWS. Okay. Similarly, I have to show that ThinkSpeak. So ThinkSpeak is available. I'll go through Google. Okay. ThinkSpeak here. So ThinkSpeak is also one such cloud service provider by MathWorks. Okay. So your smart connected devices connected to a ThinkSpeak cloud. I don't know whether so this password. Check whether it's to check this. Okay, maybe there's something wrong with the password. Anyway, I'll show you in the next class. Okay, there's something issue with this. Okay. So these things which I'll discuss later on. Okay, so first I'll complete AWS IoT core. Okay, so anybody having any doubts so far? Whatever we have discussed so far is we have created a policy. Okay, then we have created a certificate and we attach the certificate to the policy. So we have a complete steps are there. Okay, before attaching the device to the AWS IoT core. Okay, but you must have an account in your AWS. Okay, you create an account. Okay, then you can go for AWS Management Console. Okay, so in the AWS Management Console, you'll find all these services. So anybody having any doubts so far? So all these are very important because they are cutting edge technologies. Yeah. In cloud computing also I mentioned how to create instances. Okay, the EC2 we have discussed, the S3 we have discussed. Okay, so now we're discussing about AWS IoT core. Okay, so coming to the networking basics, uh, we have discussed that we have different classes of the network like A, B, C, D. Okay, and if an IP address is given, then we can find out what is a network ID. Okay, what is a how to find out a subnet mask. Okay, then how to convert uh, an IP address to binary. Okay, so that is very easy. So, so some fundamentals that we have discussed. For instance, 192.168.37.200. Okay, so some IP address is given. Okay, so to which class it belongs to? To which class it belongs to? It belongs to class C. Okay, it belongs to class C. Okay, you can refer to the previous lectures. What are the different classes I have mentioned? Okay, now how you're going to convert? Because if we talk about class C, then these three are network representation and this one is the host ID. Okay, so there's a class C. Okay, now you have to convert this into binary. How to convert this? Okay, so you know that 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7 is okay. Okay, started with 0. So because every octet is of 8 bit, so there's 8 bit, there's 8 bit, there's 8 bit, these are all of 8 bits. Okay. So what is this? A decimal of this is 1, this is 2, this is 4, 8, 16, 32, 64, 128. Okay. So first one is 192. What is a binary of 192? Okay. So here you see if you add 128 with 64, you'll get 192. Okay. So this is the arrangement of 8 bits in an octet. So in the left mode, if you add 128 and 64, you will get 192. So what you will do, I'll put 1 here, and the rest I'll make it 0. So this is nothing but your 192. Okay, this is very simple and you have to follow this. Okay, then what is 168? So you see here which two can be added to get 168 here. Okay, so you have 128. What you want? You want 168. Okay, so 40 is required. So 32 and 8. Okay, you see where this 128, 32 and 8 is there. So you add 1 there and you put rest 0. So this is your understood. This is very easy. Okay, you just write this 8 bits into 1, 2, 4, 8, 16 because they're all written here. Okay, now whichever the octet you want. Okay, you just keep on adding this whether you're getting that number 128 plus 64. I'm getting 192. So you select this number, you write 1 1, rest you write zeros. Okay, because your network ID indicates with 1 and host ID indicates with 0. Similarly, your next is 168. So you see 128, then I can require 40. So that is 32 plus 8, 32 plus 8. So wherever that numbers are there, decimal numbers, you put 1 there. Okay. So next probably I've written what I've written 37. So देखिए 37 कैसा आएगा? So 32 plus 4, 36, then 1. So 32 plus 4 है 36 हो गया plus 1. So wherever you find these numbers, you put 1 there. So यहाँ 0 है, यहाँ 0 है, and here it is 1, 0 because I have to put 1 here at the 4, 0, 1. So this is your 37. So like this, you can convert all the octets into a corresponding binary form. Okay, so I have converted 190 to 137. Similarly, 200 also. So you can convert 200 also by choosing these decimal numbers. Okay, so whichever number is responsible for getting the 200, you put 1 there. Okay. In this case 128 हो गया, 64 हो गया, ठीक है, और we require 8, so it becomes 200. So wherever you find 128 is this, 64 is this, 0, 0, then 1. So this is 200. See, so all the octets are converted into binary now. Okay. So this is a very simple mechanism. You have to remember how this is converted into binary. Okay. So subnet mask we have already discussed. Okay. For instance, if I write 115.10.20, so this is actually belonging to the class A. Okay, so class M is first work in network ID and the rest is host. So if you want to create a subnet mask, so you write 255 here, then all becomes 0. So this is a subnet mask. Okay. So we have subnet mask is there and we have subnetting is also there. So we do subnetting in order to distribute a single IP to various networks. Okay, so this we'll discuss in the next class. So anybody having any doubts so far? Otherwise we'll stop here. So we'll stop here. Take care. Bye bye.